In this video, we are going to study how to calculate present value or present worth of a given cash flow diagram. So let's quickly read this problem. We have a cash flow diagram here. Find the present worth of the following cash flow diagram if I, letter I indicates the interest rate. If interest rate I is equal to 8%. So it's a very easy problem actually. Not much information is given in the problem statement. All we know is the interest rate, which is 8%, and then we have this cash flow diagram. So first of all, if you look at this cash flow diagram, there are 10 time periods. They can be years, they can be months, weeks, quarters, depending on the context of the problem, right? It doesn't matter. So we have 10 time periods, and on a cash flow diagram, positive cash transaction or a benefit is represented by arrows pointing upward, and the negative cash flow or the costs are indicated by arrows pointing downward. So in this particular cash flow diagram, we don't have any upward arrows, right? We have all the downward arrows. That means all of these are cost items. Second, the length of the arrow indicates the amount of the cash, uh, whether upward or downward, right? So, for example, $100 cost is less than $150. So, the arrow that indicates $100 is smaller than the arrow that indicates $150. So, very simple. This cash flow diagram, we don't have positive cash flows. So but you will come across cash flow diagrams where we have positive as well as negative cash flows. Also, during some time periods there may not be any cash transaction. So all kinds of things you can find, but let's just focus on this cash flow diagram. So uh, different cost items have happened in different time periods, and we want to find out their present value. And you, as you know, present value p, present value is indicated by letter p, right? So we want to find out the p value. That means all these cash flows, we want to bring them back to time period 0. We want to find out what will be the equivalent p value, what will be the equivalent present worth, present value of all these future uh, cash flows. Then, as you know, the cash flow that happens not in the present period but in future period is indicated by F. So we have, for example, this one is, if this is P, time period 0, the present time period, then we have F1, F2, F3, F4, and so on and so forth. Then there is another letter that you are familiar with, which is letter A. If we have a cash flow that is same amount every time period, like the rent, monthly rent that you pay, uh, that can be considered as a value, right? It's basically the same amount if you are spending or if you are earning, whether negative or positive, but the same amount every time period. If we have such a case, then that can be represented by A. And then there is another letter called G, arithmetic gradient. So before I discuss G, let's see if in this case we have a P here. Right now, $100 is in the -100, but since all of them are cost, we will not worry about the negative sign, right? Uh, we will just call it cost, so it automatically becomes negative. So only cash flow transaction that is in the time period 0, which is P, is $100. Now let's talk about, we all know that these are future F1, F2, F3 future cash flows, but is there a pattern, is there something common like A, which we uh, the same amount every time period, right? So I am going to look only up to time period 5 first, and you will see that from time period 1 to time period 5, $150 is common, right? 150, minimum $150 cash flow negative cash flow is happening in each time period, right? 150, 200, which is greater than 150, 250. So there is a, if there is any a, that would be 150, and we are only talking up to the time period 5 here. Uh, we will solve the rest of the problem, like we will solve this in a two-step problem. We will consider time period 0 to 5. Okay. And then try to bring all these cash flows back into their present value, and then we will try to find the present value from time period 6 to 10, those cash flows, their present value. That present First we can bring them back to time period 5, and from there we can so basically what all the cash flows during period 6, 7, 8, 9, 10, we will first find out their equivalent value in time period 5. And then once we know the equivalent value in time period 5, from there we can bring it back to time 0. So what will be the equivalent value in time period 0, right? So as I said, first let's focus on these first 5 time periods. So a would be 150, that is common among all these cash transactions here. And then the g is called as arithmetic gradient. So if we have something, uh, some cash transaction that is increasing or decreasing by same amount every time period. So here you will see the cost is increased by $50 from 150 to $250, then 200 to 250, $50, 250 to 300, $50, and 300 to 350, $50. So there is a constant increase of $50, which is called as arithmetic gradient. G, letter G. So we can put that as a dollar 50, right? Uh, so these are kind of things that we know from the cash flow diagram. Of course, there is other, this side we haven't even looked at. So one way to solve this problem, an easy way, but it takes a long, it takes, it's a cumbersome calculations. So but it is easy to understand, is take it, consider each cash flow individually. $150 and bring it back to 0 period, then $200, bring it back to 0 period, right? Its equivalent value. So we have these 10 different cash flows. We treat each one of them separately and bring it back to its time period 0. So just to show you, let's consider these first uh, three time periods, 0, 1, and 2. So let's say we want to calculate the present worth of these first three cash flows, right? So then P is equal to what happens to $100. $100 is already in time period 0. So they will be added as it is because they're already p value, right? They're already the present value, so they don't need to be discounted back. So that's good. Then we consider 150 as our separately as a future cash flow f1, right? F1. So let's consider that as a f1, which is basically $150. And since this is a future value, we need to multiply that by p given f factor. Find p given f. We need to multiply this future value, f1 value, $150, by p given f factor at 8% interest rate, that is given, right? At 8% interest rate. And uh, time period, how many time period we want to discount it back. So we just need to take it back one time period back, right? One time period from 1 to 0. So that would be one time period or 1 year or 1 month, whatever it is. So that is that. So this gets added as it is because it's already in time period 0. This $150, we are multiplying that future value by p given f factor at 8% and discounting by 1 year. Then let's take a look at the third one, plus $200, right? So 200 Once again, that's a future value in time period 2, so we can call it f2. To bring it back to time period 0, its equivalent value, we need to multiply that by p given f factor, same interest rate 8%. Only difference is we need to discount it back two time periods, so that n would be 2. N basically is uh, the time periods, right? Time periods. And the formula, as you know, p is equal to future value f future value, some future value in time period f, multiplied by p given f factor at I interest rate and n time period. So any future value can be we can find its equivalent p value by multiplying it by p given f factor at the given interest rate I% and the time periods, like how many time periods we want to discount it back. So that is the formula we are using for each of these cash flow. So interest rate is not changing, only thing that is changing is n, time period 1 here, time period 2. So that would be, if we want to find the present worth of these three cash flows, that's how we would do it. And if we want to find present value of all the cash flows, then we keep adding 250, multiply by p given f factor 8%, but now time period would be 3, and so on and so forth. So we will have uh, 10 different terms, uh, 10 terms plus this present value is 100. And we can then go to the compound interest tables, which you can google it and find it. We can go to them and search for p given f factor, right? P given f at 8%, so we have to go to 8% table. So this one is 1/4% or 0.25%. So I'm going to scroll down until we get to 8%. Let me scroll down quickly. So here we are, 8%, and then p given f, right? So for n is equal to 1 year, that would be 0.9259. So you would put that here, 0.9259. For 2, n is equal to 2, second row, 0.8573. So that's how you plug in the factor values, and then you can calculate the present value in that fashion. But since there are too many terms, it's just too much work. So I'm not gonna use that approach. I'm going to use an approach that is shown here. So in this approach, first $100 are in the present value. They are listed as it is. Then I'm gonna take this a 150 common, and as I said, I'm only focusing on up to time period 5, and then we will worry about the time periods that are beyond time period 5, right? So uh, I'm, I will take that a value 150, that common 150 across all these cash flows. So 150, and since this is a value, right? Same amount in every time period, we need to multiply that by p given a factor. Find p given a is given, and we want to find out its equivalent p value. So multiply by p given a factor at 8%. And why 5? Because 1, 2, 3, 4, 5 time periods we are considering, so that's why 5. Okay. So that takes care of that 150 from each cash flow. But then we have to also consider the g value, so the value that is arithmetic gradient, which is $50 here. As you know, it's increasing by $50, and we have to take that g value, which we did here, and we have to convert that g value into its equivalent p value. So for that, we can multiply that by p given g factor. Find p given g factor at 8% and 5 years, again 5 years. So that will this simple formula here, this $100 as it is, then the common a, we multiply that by p given a factor, and g value we multiply that by p given g factor, will give us the present value of all these first five cash flows, right? Then let's talk about cash flow 6 to 10. So as I was saying before, we first bring these cash flows to time period 5, find their equivalent value in time period 5, and then discount them back to time period 0. So here is how we can do it. Okay, so we have 300, 250, 200, 150, and 100. So if you consider a common 300, for example, common 300, which would be a value, then right, in that case it would be a value 300. And then uh, you will see that it's e- every time period it decreases by $50. So 300, then 250 minus 50, then another minus 50, 200, and so on and so forth. So we have a arithmetic gradient, that is in this case would be minus $50. So we consider 300 a, and then minus 50 g. Okay, and we are trying to bring everything back to time period 5 here. Okay, so common a, which is 300, because it is a, we need to multiply it by p given a factor, 8% interest rates are same, and 5 time periods, right? 1, 2, 3, 4, 5. So n is equal to 5. So we can, of course, these factors we have to find their values in the table. So that is that. Then g minus 50, minus 50, and it is g value, we want to find out its equivalent p value in time period 5. So we multiply that by p given g factor at 8% and 5 time periods, right, up to this point. So now everything is back at this period, this 6, 7, 8, 9, 10, we have their equivalent present value here. But this is a future value. If you are looking at it from the time period 0, it is future value in time period 5. So now we take that equivalent value, which is f, this is whole thing is f, looking from the time period 0. And since it is f, we multiply that by p given f factor. So multiply that by p given f factor. Interest rates are same, and n is equal to 5. How is that 5? Because we take that p value and bring it back to 1, 2, 3, 4, and 5 period. 5 period back. So that's why it is 5. So now we have this expression that takes care of the entire cash flow diagram. Now all we need to do is plug in the factor values and solve the problem. So I will copy paste it here, and we will plug in the values. So we are already at 8% uh, interest rate table, and we want to find out p given a factor for 5 years. So p given a here, present worth factor, find p given a, 8% p given a, and for 5 years, 5 years. So that's 3.993, 3.993. So I will copy that, and I will replace p given a by 3.993, and same thing here, p given a 8%, 5 is 3.993. Then let's find out this factor p given g. So we look at gradient present worth, find p given g for 5 years, right, time period, 5 time periods. So that's 7.372. So I'm gonna copy that, control C, and we can replace this by that value, Same thing here. And lastly, we want to find out what is P given F. uh, P given F, present worth factor, find P given F, time period 5.6806, 0.6806. So let me replace that. Okay, so we have plugged in the values. Now it's a simple expression that we need to solve. So let's solve this further. P is equal to, let me pull up a calculator. So I will do this these complicated terms first. So that's gonna be uh, 300 times 3.993 minus 50 times 7.372. Okay, it something seems to be odd about this calculator. Why don't I simply copy this and put it in Google here? Okay, and get that calculator. 100 plus 150.3993, which we have, plus 50 times, let me make it bigger for you so you can see here, plus 50.737200 plus 300.3993 minus 50.7372 times 0.6806. Looks good. That is our final answer then. Control C and Control V. So I can round it up to the two decimal places, and that is the present value of this cash flow diagram. Now this is just one cash flow diagram, but it should be easy, no matter what different cash flow diagrams you get. You should be able to find its present value. You All you need to do is, either you can consider each cash flow separately, and that will be future cash flows, and you can multiply them by P given F factor. That's the easiest way, right? And this is actually negative here, but since everything is negative, we will just, this is a cost, we know, right? But if some arrows are pointing upwards, some arrows are pointing downwards, then you have to be careful when to use plus, when to use minus, things like that. And if you see some patterns like A and arithmetic gradient G, then you can apply that to simplify your problem. But if that's too complicated for you, treat each cash flow separately, bring it back to its zero value, and then add them up all at the time period 0. So this is where I will stop. Thank you.